Hello friends, myself R.D. Mahajan, Assistant Professor, MIT Aurangabad, presenting my next video on the topic Inverse Laplace Transform of unit step and displaced unit step function part 2. Let us solve some examples on this topic. First one, find inverse Laplace of s e raised to minus 2s divided by s square plus 4s plus 5. Again in the same form, and therefore using that result, here f bar of s is s divided by s square plus 4s plus 5. We can't find the real factors for this denominator term. Therefore, we find out the last term by the formula middle term square. Here the middle term is 4s square divided by 4 into first term. First term is s square, and therefore we get 16 s square divided by 4 s square. S square get cancelled. 16 by 4 we get 4. Therefore add 4 and subtract 4. This term we can rewrite as s divided by s square plus 4s. We add 4 and subtract 4. Therefore I will add 4, I will subtract 4, so that no change in the original result, original term, and plus this 5 as it is, and therefore it is equals to s divided by, if you consider the first three term, it is the perfect square of s plus 2 whole square. If you expand it, a square means s square, twice ab we get 4s, and b square means 4, and 5 minus 4 we get 1. Okay. There are two terms of s, in numerator s and in denominator we have s plus 2. Therefore everywhere s must be replaced by s plus 2, and therefore I will rewrite this s as s in the form plus 2. Therefore I will add 2, I will subtract 2, so that no change. Therefore it is s plus 2 minus 2 divided by s plus 2 bracket square plus 1 square, and then taking separate division, we have s plus 2 whole divided by s plus 2 whole square plus 1 square, and second one is minus 2 divided by s plus 2 whole square plus 1 whole square, and then finding inverse of this means inverse of this, and therefore inverse Laplace of f bar of s means the inverse Laplace of this two term, taking separate inverse of the first term s plus 2 divided by s plus 2 whole square plus 1 square, and minus 2 constant term outside, inverse Laplace of 1 upon s plus 2 whole square plus 1 whole square, and then as s replaced by s plus a, it is a problem of shifting theorem from inverse Laplace transform. Therefore it is e raised to plus a means e raised to minus at, a is here 2, therefore e raised to minus 2t into inverse Laplace of the remaining. If you remove 2 from this, the remaining term is s upon s square plus 1 square. Same way here, e raised to minus at e raised to minus 2t into inverse Laplace of 1 upon s square plus 1 square, and therefore it is equals to e raised to minus 2t. I can take common from this 2. Inverse of s upon s square plus 1 is cos at is 1, therefore it is cos t, minus 2 times 1 upon s square plus a square, its inverse is sine of at, sine of t, and we call this is f of t. Okay, here first part I have completed. I have obtained the inverse Laplace of f bar of s, and we are calling it as f of t, and then applying this result, fourth result, and therefore inverse of s e raised to minus 2s upon s square plus 4s plus 5 is equals to f of t minus a is here 2 into u of t minus a, and it is equals to replacing t by t minus 2, we get 2 times e raised to minus 2 times t minus 2 into cos of t minus 2 minus 2 times sine of t minus 2 into u of t minus 2, and again final result considering two values 0 and 1. When it is 0, this term becomes 0. For t less than a is here 2, and when we consider the second value as 1 into this, we get e raised to minus 2 times t minus 2 into cos of t minus 2 minus 2 times sine of t minus 2 for t greater than or equals to 2 is the required inverse Laplace transform, or the required answer. One more I will discuss. Find inverse Laplace of 2 by s cube plus e raised to minus s multiplied by 1 by s plus 2 by s square and minus 2 upon s cube. Okay, and therefore to find the inverse of this, we try to get the inverse of this first term as well as inverse of second term. We have inverse Laplace of 2 by s cube, 1 by s cube, its inverse, here it is positive integer, t raised to 3 minus 1, that is 2, divided by 2 factorial. Okay, and just to get cancelled, we get this as t square. Applying this result, inverse of f bar of s is f of t into u of t. You can write only t square or multiplied by u of t. Okay. First result. We try to find the inverse of the second term. Here f bar of s is 1 by s, 2 by s square, 2 by s cube. Finding individual inverse. Inverse of 1 by s is 1. Inverse of 1 by s square is t, and minus 2 times inverse of 1 by s cube, t raised to 3 minus 1, that is 2, divided by 2 factorial 2. And we can rewrite this as 1 plus 2t minus 2 to get cancelled, t square, and we call this as f of t c. And therefore inverse Laplace of this term e raised to minus s into 1 by s, 2 by s square minus 2 by s cube, using the fourth result. F of t minus a is here 1, therefore t minus 1 into u of t minus 1, and it is equals to, replacing t by t minus 1, we get first term 1, 2 times t minus 1 minus t minus 1 bracket square into u of t minus 1, and therefore using two values, first one 0, this term becomes 0. For t less than a is 1, and second value is 1 into this term, we get 1 plus 2 times t minus 1 minus t minus 1 bracket square for t greater than or equals to 1. If you call this one as equation 1 and this one as equation 2, and then we add these two, therefore inverse Laplace of 2 by s cube e raised to minus s in bracket 1 by s, 2 by s square minus 2 by s cube is equals to addition of these two results. The first one is t square ut, and second one is this one. We substitute, instead of substituting this value, we substitute this. Therefore, it is 1 plus 2 times t minus 1 minus t minus 1 bracket square into u of t minus 1 as the required answer, a required inverse Laplace transform. Therefore, with the help of all this example, I have explained how we can obtain the inverse Laplace transform of unit step as well as displaced unit step function. Okay. In next video, I will explain, or I will discuss Dirac delta function, its Laplace transform as well as inverse Laplace transform. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel for latest updates. Thank you very much.